So Harpreet gave just a brilliant talk right now about how to build a module. I'm going to sort of be a little bit more technical and nerdy about this and focus just on IBC. And IBC is sort of the last sort of integral component in this Cosmos vision, and it's the whole idea of being able to allow all these sovereign blockchains to connect to each other, exactly as Tobias said beforehand. Just a quick introduction of myself, though, and a bit of a preface. I am not the IBC Protocol Architect, so if you want to sort of get into the nerdy details about it, I can only go so deep. My background is actually for the Tendermint core team. So Tobias, just for a little bit, mentioned the Tendermint core, the sort of consensus engine that makes sure that state machine replication happens in a Byzantine fault-tolerant environment. So I'm great when it comes to that. We'll see how this goes. So I think before even diving into like how you're going to build a module, let me just explain what IBC is. And I'm not going to say like how it actually works. I just want to say how you should think about it, how you should think it works. And maybe before I start that, let's think about how we think a blockchain works. So a blockchain is essentially just a computer. It's a logical computer with many physical computers, decentralized in a lot of different places. But you can think about it as just a logical computer. It has state, it processes things, it makes state transitions. Just the same way, it's a very special type of computer, maybe like a quantum computer, something like this. It just has a lot of nodes all over the place, and it's good for making environments where there is Byzantine actors at play, and you want to be sort of adverse, or like fault tolerant to this. So you have this sort of computer, and the way you can think about an IBC module in the Cosmos SDK is a little bit like you can see a network card. So you have a little network card that you connect with your computer. Because at the moment, your computer is all just by yourself, and you can sort of play around with that in that environment, but you can't sort of move out to anywhere else. So once you've got this network card, that sort of then sort of allows you to sort of now connect with other computers. And this is how you should think about IBC. You sort of plug that module in, and then you can sort of start plugging in with other sort of computers. There is one last component between this, and this is the relayer. So the IBC is just, the module itself is just a bit of state. So it just saves these like messages in this like kind of like a buffer, like a queue, and you have this relayer process which takes messages from one blockchain and moves it across to the other. And then it does this sort of like delivery, it opens channels, and it makes sure that the service is delivered. It's a little bit like TCP. So you have UDP, which has kind of little guarantees that a message will be delivered, and TCP has a little bit more to this. So this is how another way you can view it. There's about where the analogy breaks down. Like at the end of the day, it's not exactly like a network chip. There are some slight differences, and we'll probably explore this more as I sort of talk about it. But I just think this is a great way to sort of like give an overarching introduction about what IBC is, and sort of like the mechanics behind it, how it works, and how you should view it. All right, so now we've sort of got like a high-level idea about what IBC is. Let me just sort of jump into like what you need to know, because you as the sort of hackathon developers, you want to know like how do I actually start using it, and what are the sort of the tools that I need to sort of get it going. And if you have some sort of familiarity with how modules are constructed on the Cosmos SDK, if you've just been following Harpreet here, the IBC is a module just in itself. The same way that Spunky is an module, it just has a couple of different messages, it has a couple of different ways of doing it that's a little bit more complex. So if you want to set up, you've got your application, your app.go, and you want to add IBC to it, it's just really simple. You just import ibc.go and then just put it in that abstract. So you have your IBC keeper, and transfer keeper is an IBC module. It's the transfer module which allows transfers of tokens from one IBC, supported blockchain to another. And then we have these like scoped IBC keeper and scoped transfer keeper. And the way this is done is that IBC, these modules are designed in a way where it's supposed to be like fault tolerant to the modules within it. So what you have is this capability keeper, so it's a capability module, and this gives certain capabilities to IBC so we can open certain channels without any conflicts of other modules opening that same channel. Probably details we don't need to go into too much depth into. So yeah, simply just import the struct, and you want to grant capabilities, you register routes. So just like you can see, the Cosmos SDK is essentially just a router that just works above Tendermint. So all it is routing messages to the adequate module. So message comes in for the Spunky one, and it goes to the Spunky module. Message comes into the bank one, goes to the bank module. IBC is a module on top of this, and it also does the routing of any IBC message. So an IBC message is a message that's transferred from one blockchain to another. And it just sits there, and then it routers out to any of these IBC modules that you want to build. So the transfer module is an example of this. So you can see here, you add the route. It has the IBC transfer type name, which is the module, the transfer module. And then you just set it as the router. And then the last thing, which you'll sort of learn if you're creating modules as well is that you need to add it to a module manager, and you need to set the ABCI ordering. Now, this sounds a little bit too much, and so the Starport team have done a great job of being able to sort of simplify this into a single command. You sort of just Starport app, GitHub, whatever, this is my sort of handler, and just my app, and that's already, you have IBC in it. So there's already got IBC, it's already got the transfer, that's part of like the standard library of applications. And then if you want to create a module, just as Harpreet sort of explained beforehand, you have Starport module create, transfer is the name of the module in this case, and you just do --IBC. And that sets up all the scaffolding for what we're about to explore now about how you actually hook your module and connect it to what the IBC stuff does. And that's just done through this interface, essentially. And I'll go into what this interface looks like, but let's just do a little bit of high level here. So that module does, the scaffolding does the job of creating the keeper and binding ports. So a little bit more detail maybe might be required than my whole like network card, sort of Ethernet LAN cable relayer analogy. The way that the IBC works is that you have channels and you have ports. And each module generally defines its own port. So the transfer module could be port 1. And then what you have is you have this whole like protocol where you might have blockchain A with port 1 of the transfer module, and you have blockchain B with a port there, and then a channel basically is just linking these two ports together. So when you're starting a connection, when you're like initiating an IBC module, you're initializing the ports, and then when you're starting a actual like connection between two of these blockchains, it's over a channel, and the channel is between these two ports. And so when you're actually setting up your module, you want to say, okay, what is my port? And you want to pick a port that no one else has picked, else you're going to have conflicts. And then you want to sort of implement this sort of IBC module, which is what the IBC module itself will do a whole bunch of like callbacks into your module itself. And the way that it sort of works is you have this 4-step process for a handshake. So whenever module A wants to talk to module B on a different blockchain, you first set up that channel through a handshake the same way you might do with TCP. So you like send the initial, like you try, you acknowledge, and then you confirm. And I'm going to go into this a little bit more later. And then you have a 2-step closing handshake. So when a handshake closes, that channel is done. No more messages can be sent across it from that blockchain A to blockchain B. And then this last part is just add whatever logic that it is relevant. And this is going to be completely up to you and how you want to design it. I want to give maybe a few examples of current IBC modules that have been implemented and why they're cool and what sort of cool things they can unlock. But this sort of part is mainly for you to sort of implement. So this stuff is all done by the Starport. So what they do is they set up their keeper, and you've just seen that keeper beforehand, so that's just where all the state is stored. And if you can see, you have the channel keeper, the port keeper, so I just mentioned these channels and ports. And for example, this is the transfer keeper, and you have the account and bank, so these are the other keepers that it relies on. So it sometimes queries the account and bank. If you want to send tokens across, then it needs to mint new tokens with the bank, and vice versa. And then we have the binding of the ports. So this is also all done by the Starport stuff, but I just wanted to sort of show you what happens. So basically, you take the Genesis state, and then you sort of take the port ID from the Genesis state and you set that into memory. This thing does the thing of creating a whole bunch of denominations. So for example, if you've got the Cosmos hub and you know there's a whole bunch of other networks that have different denominations, like Osmosis has Osmo, Terra has Luna, you might be able to set these up straight away so that when tokens are transferred into the Cosmos hub, you recognize those denominations. But this is something that's just logic for the transfer module. Then this important thing that's already there is you want to make sure that no one else is bounding to that port ID. So when the blockchain starts, it can't have another like transfer to module that uses the same port. Each port has to be unique. And in this instance, we panic if it's not. Then there's a bit of other logic like params and whatnot. And then that's how we sort of like initialize. And so now let's look at like the sort of like flow of like setting up a channel. So you imagine we've got these two blockchains, and they're each uninitialized. They're not connected with each other. They're two little separate computers that have no idea that each other exists. So what happens is one sends a message across the other one. This is the init message. And the way that's done is that it's sort of like anyone can initialize a channel. It's permissionless. So I sort of send a transaction because I want to send a token across. I send a transaction to my blockchain A. That then puts that onto the IBC. A relay grabs the message from the IBC as a packet and then sends it across to the other one. And so that message that's been sent across is the initialization. And then on the other end, that module receives that and returns something known as open try. So it's trying to open a connection return. So it's seeing that like someone's trying to connect with it, and it's trying back. And this message is sent across. And then you have the acknowledgement once more, and then the confirm. So there's 4 messages sent every single time you want to start a channel. Once that channel is started, though, you can just keep sending things across, and both of those modules are aware of each other. They're like, okay, we know that that's trying to send to me, and I've chosen whether I want to accept it or not, or refused it. So each module has its own sovereignty about whether I want to actually have connections. Same way a blockchain might have sovereignty about whether I want to actually receive tokens from Osmosis or Luna, or Terra, sorry. And then there's the closing of it. And so once you want to close a channel, in the same way, you just have a 2-step process where someone inits, and then the other one confirms. And now that channel is no longer, and that channel can be used for some other thing. So I'm going to dive a little bit into like what this looks like, and trying to use the transfer module in this example because it's relatively simple compared to something else out there. So you have this open channel init, and there are some sort of various properties of channels. So the 2 main ones that you want to look at is there's an ordered channel and an unordered channel. An ordered channel means that the messages coming across from blockchain A to blockchain B must be in the order with which they're like submitted on the IBC module. Unordered means that like the relay can deliver them in any order. It means it can grab this one and then this one. Like you got to understand there might be multiple relays trying to send stuff across, and you might have conflicts about this. So, and for the transfer module, it's fine just to have an unordered thing. So it doesn't matter if you send your token across before someone else does, just as long as it sort of happens. And so what we have is generally this sort of like check arguments thing. So you check that the channel is unordered. You might want to check versions. Like this is something that you sort of think about in the future, not maybe when you're initially starting to write these things, but your module might have multiple versions. It might start off version 1, then version 2, and so part of this handshake is making sure that you're sort of compatible with each other. And then the last thing that is like something that you need to do is you need to go to the claim capability and claim that channel. So now it's kind of like a locking system. So now I'm locked onto this, and I hold the lock, and I can now do whatever I want in terms of message passing. This channel open try, so if we're looking at like blockchain A was the initializing it, this is the blockchain B, which then tries to return it, and it does the same thing, where it's, okay, that I'm now claiming that port, or like channel, rather. So now we've both locked onto those channels, so there's like a distributed lock between both of these things. So they're now agreeing that this is the channel we're going to pass things across. So now the relays know, okay, I'm going to pass this thing across to the other one. And then you can just sort of add any other sort of checks you might want to do. Same as I said beforehand about versioning and whatnot. And then trying not to like make it go too elongated, you have the acknowledgement, which is much the same, and the confirm. I don't think sort of need to go into too much details about these. And in fact, when it comes to the transfer module, the acknowledge just checks the counterparty version, and the confirm just returns. Like once it's confirmed, there's nothing else you need to do. So in many cases, these are very simple just to fill out. And then we have when you're closing. Now, the transfer module is quite interesting. You can't close a channel. Once you start a connection, once a connection is made between, for example, Terra and Cosmos Hub, it can't be closed. No one can close it, although you might want to do something different. You might want to have some way where you can do, depending on what you're trying to send across, you can have it so that the sender who started the channel can then close it afterwards. But this makes it very easy to implement. You just return an error whenever someone tries to close that channel, and this is just return nil. Okay, now for like the interesting stuff. So you got this boring logistics of like this handshake. How do I actually send data across? So basically what you want to do is in your keeper, you also want to take in the IBC keeper channel keeper. I sort of mentioned this beforehand. And essentially you're using that reference of the IBC keeper to send packets. So you grab your like data, and so for example, this could be the high score, which that was a sort of like struct, and you sort of wrap that around in this packet, and then you just simply use that API send packet, and then it's on its way. Okay, but imagine now you're the receiver to this. There's one of 2 things that can happen. The packet never arrives to you because it times out, or you like get it and it's a success. And so there's 2 things now that you have to worry about in your module when you're receiving packets. or like when you're sending packets. So everything is two-way. So when you're sending packets, the things you gotta worry about is acknowledgements. So whenever you send a token across, there's going to be acknowledgement that that token actually reached its destination and was processed by that blockchain. And then in which case you can be like, okay, like if you're doing a transfer, you're like, okay, that transfer was complete. If the transfer failed, you're gonna have to give that person back their token. Like imagine they're trying to send atoms across onto the Terra. Then if that failed, we can't just keep their atom away, we have to kind of give it back to them. And then similar with the timeout, so timeout is just another form of like failure in this case, and in which you'd have to sort of give back the sort of atom that they tried to send across and be like, sorry, try again later, maybe there's something wrong with the relayer. Okay, so that's sending packets, so that's one end of the problem, and then the other end of the problem is receiving packets. And this is just done as another callback function. So you just sort of outline this in your interface, and this will like call whenever someone sends it across. And just like how I said you might receive an acknowledgement, now you're the one sending the acknowledgement back. So once you've processed that like packet data and done whatever state transition you need to do, updated what you need to update, you then return an acknowledgement, either it succeeded or it failed. All right, and then now comes into adding all the remaining logic. And this is what we sort of like, I'm going to implore on you guys to sort of work out what sort of fun stuff you can do. But before I sort of do this, I want to talk a little bit about some of the existing IBC modules and what they're doing. I already covered briefly how transfer works. It's kind of a very simple concept to understand, which I think is a great sort of starting point. You're basically taking tokens from one and moving across to the other. But there is a whole sort of like plethora of other things you can do. So few helpful pointers when you're sort of starting with building your IBC module is just to like abuse the hell out of Control-C, Control-V. This is how I sort of hack at everything, how I learned about the Cosmos SDK, as I just copied the bank module and I started changing things and see what happens. And I implore you guys to all do the same. Same way for just seeing how other IBC modules do it. So I've just discovered transfer module. So there's two other really cool modules that are sort of in production at the moment. There is interchain accounts. The concept of interchain accounts is you can have one account on a blockchain that represents the entire blockchain. So you have a governance module, and governance is used to vote things, to change on parameters. It could be an example of a game. You want to change like how high scores are calculated. Now, governance can also be that all those accounts on one chain represent one account on another chain. So together they can like say, as a sort of community, because that's what sort of blockchains are, we want to do this action, and then it's sort of reflected on that other chain, and we use IBC to do this. Another one that's very interesting is interchain security. So interchain security is very similar to what sort of like other networks are trying to do, where instead of this problem where like you need to find a validator set, how about use a validator set of an existing blockchain? And this is something that the Cosmos Hub is sort of aligning itself with in the whole sort of mission of let's try help as many other blockchains get off the ground as possible. And so what interchain security is you take the validator set of, for example, of the Cosmos Hub, and that validator set is used, or whatever sort of portion of that validator set that is interested in starting whatever chain you have. And so the way it works is that chain, child chain or side chain or whatever you want to call it, has a record of that validator set of the main chain. And they use that validator set to do their state machine replication. What happens if there's something sort of wrong happening on this, then this child chain sends evidence across to the parent chain. And now the parent chain can do whatever sort of slashing and whatever of the stake of those validators on that main chain. And then that goes back and that gets confirmed, and then there's a validator set update, and now you do that accordingly. So what that means is that you have, I don't know, a few billion secured in the Cosmos Hub, that now can be used to secure any sort of child chain as it sort of grows its community. So when it starts, its token is going to be, depends on the sort of day or whatever, but very low value, and then, but very sort of like, vulnerable to sort of attacks. There doesn't need to be much sort of wealth required to sort of attack it, but you can now sort of start with the wealth of an existing chain that's already very much in the, sort of dominates its space, and use that to sort of like protect the chain as it grows up. It develops its own validator set, and then eventually it can sort of move away from that parent chain and have its own sort of like sovereign system. The last thing that I just wanted to talk about is just to use the docs. I'm generally quite scared when it comes to like using docs. I'm like worried about what sort of level of technical depth, but I think the IBC team have done a really tremendous job in using the IBC docs. I used it just now to try work out what I would want to talk about. I understand IBC from the point of like light client verification and a lot of this sort of like proof stuff, but in terms of like how actually people will use it, I sort of did use the docs and relied on it a lot for that sort of thing. All right, so I finished this about now, and I would like to see if any of you guys have any questions. Of course, this is a very sort of technical overview of this, and perhaps you guys just want to approach me one-on-one. I'll be out here chilling, happy to talk about it, happy to talk about any other sort of part in the Cosmos ecosystem. I'm very much involved in all these different things. I think it's a very much an attitude of anyone in this space. They can't just do one thing. They're too busy juggling 5 or 6 different other things. So I'm happy to talk to you about this, but if you have any questions about how to sort of initialize IBC module and maybe some things you didn't understand about the channel and stuff like this, feel free to ask it now.
Just one question. Do you have any way to verify the funds that are sharing between the bridge? Basically, if some funds were like hacked on, like, let's say, Interchain, and they were trying to transfer from the Cosmos blockchain to another one, will there be any way to be sure that the funds are come from a safe place and not from like a hacker perspective?
Yeah, so the way it works, and I didn't want to sort of like dive into the verification thing, but the IBC uses light client verification to prove that every single transaction that happened on one chain did actually happen. And so the way it kind of does this is the IBC module keeps a track of all the headers on all the other chains. And so IBC relayers, they're relaying both packets, but they're relaying state updates. And so what happens is you might have these 2 chains here, and it will take the header that's produced, the next block, each block has headers which sort of verify like what was in that block. It takes that header across, and it stores it on that chain. And that chain does validates that state transition happened. So it kind of knows what is the next header on that chain, such that when a transaction comes across, I don't want to get maybe too technical, but you can use it's like a Merkle tree, and you can use a proof to work out that transaction did actually happen on that chain. So basically, it's sort of, the relay is carrying the package along with the proof, and if you have the header in that other chain of that chain there, very hand-wavy and whatnot, you can prove that transaction happened. Short to say is that everything is verified. It's not like I'm just sort of hoping that happens, then that state transition on that chain actually did happen. And the cool thing about this whole sort of IBC stuff is it's done in a very agnostic way. So when we're talking about Tendermint, that's sort of like the main application, but anyone can sort of in theory write some sort of light client verifier, which does this thing of verifying headers on the actual IBC module as anything else. So it could be a Solana light client, or it could be something Solana has light clients, but the theory holds that you could use any other sort of system. And there is a lot of work at the moment to sort of incorporate the likes of Polkadot and Solana to have their own sort of IBC module on their chain and be able to sort of relay packets between the two. Does that answer your question? Awesome. Anyone else?
Who is running the relayers? So if there are 2 blockchains and they both have their validator set,
yeah.
Who is actually running the relaying from one blockchain to another blockchain, because somebody has to inform the other validator set, right?
That's a super interesting question. So you have node operators, right? So if you're running a validator, you're running this binary, and you're spinning it up, and you're doing the whole sort of consensus dance about working out what sort of state transition should happen. Relayer is just like a node operator in the sense that it's another process that's running on a computer that someone has to run, and it does this thing of having light clients on both chains. So if you've got the Cosmos Hub and Terra, you run light clients on both of these chains, and you're doing this thing where you're basically reading the state of the IBC module and then submitting a transaction on the other module and doing that. That's exactly what relaying is. How is it incentivized at the moment? The answer to this is it's not.
Okay.
No one's actually received, and this is actually a big problem in the system right now, because the whole idea is the sort of chief sort of architects that did it, like Chris Goes, he was worried not so much about the problem of financial incentivization, he was worried about the technical problem about how you do this across securely. And he was like, I'm going to let who else is implementing it work on the finances, about the economic incentivization about it. And so there is work being done, there are design documents being written about how you can sort of find ways to give fees or some sort of thing. I think there's actually mentions about using DAOs as a way of funding relayers. But it's very much an important question, because at the moment, a lot of these things are just run on the good of the community, which is what a lot of things start off like anyway. But yeah, good question. Anything else? All right, well, feel free to talk to me afterwards. I will be staying around and enjoying the free beers. Thank you very much.